Hello, gentlemen. Purpose of this video is to continue on working with fundamental identities, and we're going to use those to do some verifying of trig identities. A little bit along the lines of what we do in simplifying expressions, except now what we want to do is show that a certain identity is true. So we're going to show that the left side of the equation is equal to the right side of the equation. So let's get started. Let's talk about some strategies to verify these identities. First, I would say work with one side of the equation. And I would say start with the more complicated side. You want to try to take the more complicated side and reduce it down to whatever is on the other side of the equation. Okay, so it's a lot more, it's a lot easier to go from something that's complicated to making it something more simple than going from something simple to try to expand it and make it more complicated. So always start with the more complicated side. Always look for opportunities to factor expression, add fractions, square. This is just basic algebra skills that we used in the past, but we also want to apply them when we're verifying trigonometric identities. Use our fundamental identities, use the Pythagorean identities, use the co-function identities. Look for opportunities to do that. Try to match up sines and cosines. Okay, sines and cosines pair well. Secants and tangents go well together, and so do cosecants and cotangents. If you have them mixed up, usually you want to go to one or the other. Okay. If you're really stuck and you don't know what to do, go to sines and cosines. It's always you have the most use of sines and cosines. You use them more often, so you're probably more comfortable with them. So if you're really getting in a bind with a trig identity, just substitute everything to sines and cosines and work from there. And then always try something. All right. Even past that, lead to dead ends will provide you some insight to finding a better way to do it. Okay, so don't just look at it, say I can't do it. Try something, and then you'll learn from every mistake that you make. So let's do some practice. And cotangent squared, secant squared minus 1 equals 1. We want to verify this. Obviously, I would start with this side of the equation. This is the more complicated side of the equation. And right off the bat, I should be looking and noticing that I have a Pythagorean identity there. Okay? The Pythagorean identity is going to be right there. All right? And what we have, if you remember correctly, that we have 1 plus tangent squared of x is equal to secant squared of x. Okay? That's not what we have, but what we have is if I manipulate this, we have secant squared of x minus 1, bring the 1 to the other side, is equal to tangent squared of x. So I can make use of that fact right here and replace that. Now I have cotangent squared x times tangent squared x. I know that there's a reciprocal relationship between those two. I know that tan is 1 over cotan. So now I have cotangent squared times 1 over cotangent squared. Those cotangent squares cancel out, and we're left with 1. Okay? Let's do another one. Cosine squared beta minus sine squared beta equals 2 cosine squared beta minus 1. In this particular example, I would try to combine like terms. And let's get everything to one side of the equation. Let's bring things over to this side. So let's combine those two terms right there. And we'll bring the sine squared to the other side as well. If we do that, what we'll see is we have a cosine squared, because we got 2 cosine squared beta minus cosine squared beta leaves me with just a cosine squared beta plus sine squared beta minus 1. We know this right there. That is simply a Pythagorean identity equal to 1. I get 1 minus 1 is equal to 0, so we verified that one. Okay? 1 plus sine y, 1 plus sine of negative y equals cosine squared of y. In this particular example, we have this term which looks a little bit odd to us, and actually it should look odd because sine is an odd function. Okay? And we know that for odd functions, we know that f of negative x is equal to negative f of x. And so we know that sine is an odd function, so sine of negative y is equal to negative sine of y. Let's plug that in. Okay. Now what I would want to do, and again we're working with this side of the equation, What I want to do is FOIL that out. And if I FOIL that out, we're going to get 1 minus sine squared y. Again, this looks very familiar to us. It should, because that's a Pythagorean identity. And that simply equals cosine squared y. And so we verified that one. Let's do one more. Sine of t cosecant pi over 2 minus t equals tangent of t. Right here, I should right off the bat be thinking about my co-function identities. Okay, because secant of pi over 2 minus t is the same as secant of t. Okay, and so if I make that substitution, I get sine t times secant of t. Well, I know what secant of t is. Secant is 1 over cosine. So now I have sine times 1 over cosine, which is sine t over cosine t, which is equal to tangent. Okay? There are a couple examples. I'm going to do another video with a few more examples, but I wanted to get you guys started. I want you to read section 5.2. Look at the different examples there. They each are going to demonstrate a different and useful strategy for identifying some of these identities. So pay attention to those. Problems, page 387, 1 to 25 odd. And so what we talked about in this video is using different strategies to verify trigonometric identities. We did some examples. The next video will give us some more examples and some more practice. So again, any questions, fellas, email me and we'll clear them up. Thanks, fellas. Have a good day.